Hello everyone, welcome back to the channel. Today we are diving deep into something that's absolutely critical in analytical chemistry, the calibration of gas chromatography mass spectroscopy. If you work in an analytical lab, you know that proper calibration isn't just a formality. It's what ensures your results are accurate, reliable, and defensible. So let's break down exactly what parameters you need to evaluate during GCMS calibration. Alright, let's start with the foundation of GCMS system, that is gases and flows. Let's start with gas pressure testing. Your carrier and detector gases need to maintain specific pressure ranges like 0 air and nitrogen. It should be between 5 to 6 kg per centimeter square, and hydrogen and helium should be between 3.5 to 4.5 kg centimeter square. If your pressures fall outside these ranges, adjust using the gas regulators. This is a simple pass or fail test. Document your result. Now let's talk about flow rates. You'll be checking 4 different gases: nitrogen, helium, hydrogen, 0 air. So if you have set your flow at 30 ml per minute, so the acceptable limit would be plus minus 0.5 ml per minute. So this will be for everyone, that is hydrogen, helium or 0 air. Use the flow meter on your GC screen to verify that actual flows match the set flows. And you have an external probe, that is your gas flow meter, to analyze your flow rate testing. Temperature control is absolutely critical in gas chromatography. So this calibration step cannot be skipped. So the external probe here that is used to record your oven temperature is digital data logger. You have to set the temperature at different levels, that is 50, 100, 200, 250 and 300. And the acceptance criteria here is plus minus 2 degrees Celsius. So in GC headspace, we are looking for 2 parameters that needs to be calibrated. First is the linearity and second is precision. So you're going to prepare 5 levels and inject in 6 replicates. So the RSD for area of your standard should be not more than 5%, and the RSD for retention time should not be more than 1%. And the correlation coefficient should be not less than 0.99. So after you've completed your system precision test, there's one more important evaluation, that is the carryover test. This ensures that high concentration samples aren't contaminating subsequent analysis. So in this, you inject your DMF, that is diluent, twice, and then you inject your stock solution, standard, twice, and then again you inject your diluent twice. So your carryover percentage should not be more than 1%. So headspace linearity you all have checked. Now for GC auto sampler, linearity check has to be done. So again, it is the same as headspace. You have to prepare 5 level standards and inject it, and the correlation coefficient should be not less than 0.99. So the standards that are used to calibrate your GC system is chlorpyrifos or lindane, and you'll inject 5 different levels. And as I told you all, the acceptance criteria should be more than 0.99. So in mass calibration, what you're checking is that the mass peak width is between 0.6 to 0.8 daltons, and your mass axis difference lies between plus minus 0.13 AMU. So in this you need to click on Auto Tune and let the system run the Auto Tune procedure. The test is automatically compared with the acceptance criteria that is set by the manufacturer. After completion, the Auto-Tune report should be saved by the default file name and the manufacturer approved acceptance criteria should be verified. This mass tune report confirms that your mass analyzer is correctly identifying ions at their expected mass to charge ratio. So in this, what is injected is your tuning solution, and there are different mass to charge ratio present in that tuning solution, which is checked. The tuning solution is called as perfluorotributylamine, that is PFTBA, and the masses that are calibrated is 502, 69 and 219. Like in GCHS system, we had calibrated precision test. So in auto sampler also we calibrate the precision, where we inject same concentration for 6 times and the RST should be less than 15%. So this is where we verify the auto sampler is performing correctly. So the complete test involves injection volume accuracy, FID detector response and vial position accuracy. So in injection volume accuracy, we set the injection volume at different levels, 1 ml, 2 ml, 5 ml, 10 ml, and we should get a linear response of that particular concentration. So there it will pass if the correlation coefficient is more than 0.99. And in FID detector response, the 5 different standards are injected and it should be linear in response. That is, your correlation coefficient should be more than or equal to 0.99. And in vial position accuracy, what we do is we prepare same concentration standard and position it at different vial positioning. And then we inject it. So the RST for area should be less than 15%. So let me give you a quick recap of all the critical acceptance criteria. For gas flow, it should be within specified ranges for each gas. Temperature calibration plus minus 2 degrees Celsius for all temperature points. In system precision, we check for linearity and RT. So RST for area count should be less than or equal to 5%. RST for retention time should be less than or equal to 1%. And the correlation coefficient for calibration curve should be more than or equal to 0.99. In carryover test, it should be less than or equal to 1% of the carryover. And in sensitivity or linearity of the GC system, it should be more than or equal to 0.99. And in system precision test of GC, it should be RST should be less than or equal to 15% of 6 duplicate. And auto-injector test, the RST should be less than or equal to 15%. So there you have it, a complete comprehensive overview of GCMS calibration. Remember, calibration isn't just checking boxes. It's about ensuring the integrity of every result that comes out of your lab. Each test we discussed serve a specific purpose in building confidence in your analytical measurement. So if you found this video helpful, please do hit the like button and do subscribe for more analytical chemistry content. Drop a comment below if you have any questions about GCMS calibration. Thanks for watching and I'll see you in the next video.